Okay, we're going to continue with R2, so we'll call this part C. For some reason, they kind of stick in a little geometry, just kind of throw it in. We'll be doing some more geometry later, but here it doesn't seem like it really fits, but they throw it in here, so we'll talk about it. Example 7, it says. I'm just looking at my notes. I'm not looking at the book, so maybe I skipped some stuff that's in the book. I don't know, but it just seems kind of odd that's just sitting here like this. But let's just talk about it because you might have a question on it. It's called the circumference of a circle. Do you remember that in geometry? Circumference of a circle. Don't tell me the equation, but somebody describe to me what I talk about when I talk about the circumference of a circle. What am I talking about? What about the outside? I can't hear you. Right, how long the outside of the circle is, okay? So like the length, I guess, of the circle. So if you took a circle, you wrapped a string around it, measured the string, that would be the circumference of the circle. Circumference means like the outside of it, okay? So that's the circumference. So if we took a circle and we found the length of the outside of it, then that's the circumference. Does anybody, you probably have your books open, some of you do, but there is a formula for the circumference of a circle. We're not going to go through the whole technical part of it, but there's a couple ways you could write it. Here's the way the book writes it, 2 pi r. Do you remember that? Or, oops, no, there's no squareds on circumference. That's area. So squared's always an area. But look at this 2r. First of all, what does the r represent? The radius of the circle. Somebody talk to me about the radius. It's from where?
It's from the middle of the circle.
Right. We say the center, but that's okay. Middle, I know what you're talking about. That we go from the center of the circle to any point outside the circle. And it's the same distance, right? If it's a true circle, it's going to be the same distance all the way around that radius. What if I took 2 of those? What's the plural for radius? Radii. Very good. So if you had 2 radii, what does that equal? The diameter of the circle, okay? So if you took one in the circle, go through the center, and go all the way to the other end of the circle, that's the diameter of the circle. So you could write this, instead of 2r, you could replace 2r with what? Say it, d, for diameter, right? So you could write it like this. You could say the circumference is pi times the diameter. Now, what in the world is this pi thing? It's the first time this year that I've mentioned pi. Well, no, it isn't. We mentioned it yesterday, didn't we? With the mug, right? The pi mug, right? So we talked about that. So what approximately, because it doesn't have an exact answer, we put a little squiggle equal sign there. Approximately, what do we say pi is? Yeah, and we usually just stop 3.14. We talked yesterday about, people memorize it to all these different places and stuff, but there's really no value in memorizing it to all those different places. I actually, somewhere I looked it up, maybe it was in a book or something. They said that scientists or computer people, people don't do this, the computers do this, but they've measured it up to trillions of decimal places. I mean, that's amazing that a computer, it would probably take forever, to get to trillion place, but there's no reason for that because you can only measure things so precisely, you know what I mean? Okay, and really, once you get past the second, third, maybe the fourth decimal place, if you get super, super precise, there's really no need to know any numbers past that. But 3.14 is important. Where in the world does 3.14 come from? Look at this, a whole book on the history of pi. Let me take a look at that. Ooh. Yeah, that'd put me to sleep in a second. I have to start reading that thing. I don't know. There you go, a whole book on it. And I don't know a ton about it, the history, but let's take a look at this. I just want you to understand kind of where pi comes from. Let's do a little bit of algebra. And I used to do this in my geometry class. I'm not going to do the demonstration today in here, but in my geometry class, I've done this before. Let's solve for pi. Let's do some algebra and solve for pi. Let's get pi by itself. So what would I need to get rid of in order to get pi by itself? The d. How do I get rid of the d? I divide both sides by d. So pi would equal what? C over d, all right? That right there is pretty important. That shows you how to get pi. You could actually get an approximation for pi yourself. So if you took a string all right, and you wrapped it around a circle. So what I used to do in my geometry class is I'd have a circle that was cut out in cardboard, right? And so I'd have cardboard, have some string, I'd wrap the string around the circle, and then I'd measure it, right? I had a meter stick, I'd measure what the circumference was. And then I would take the diameter. The diameter goes from one end through the center to the other end, and I would measure that. And then I would divide. I would take that circumference that we measured, okay? I would divide it by the diameter that we measured, and guess what I would get close to? I would get just a little bit more than what? 3. So what does that mean? That means that the circumference is how many times more than the diameter? It's a little bit more than 3 times the diameter. Okay, so if you have a circle, if you measure the diameter and you basically just multiply that by 3, you would get pretty close to what the circumference of the circle is. Does that make sense? So the distance around a circle is approximately 3 times as big as what the diameter is. Make sense? That's where you get pi. If you got really, really, really specific measuring devices, then you could get really close to 3.14, okay? When you just have a piece of string and a little meter stick and stuff, you get really close to 3, and that's good enough for us, okay? But that's how you get pi. Anybody explain that to you before? Okay, probably not. Most teachers don't, okay? But I like to do that because I like you to know where that comes from. It's not just some magical number that just appears that scientists just came up with on their own. It's an actual measurement. You actually can measure and get what pi is equal to. So that's kind of interesting. I think it is anyway. Maybe you don't. I don't know. All right, so that's circumference of a circle. Basically, what this is just saying is we just talked about domain yesterday. So what is the domain of this? Okay, what does that mean? That means, well, 2 is just a constant. 2 is always going to be 2. Pi is just a constant. It's always going to be 3.14159, blah, blah, blah. That's always going to be something. What could change, though, in order to get a different circumference? The radius. So what do we mean by the domain? What is the domain? It means what are all the numbers that are possible for the radius? Could we have square roots? Yeah, square root's still a number, right? Could we have positive numbers? Yeah. Could we have fractions? Sure. Okay, it could be a fraction of something, half a foot, quarter of a foot, or something like that, right? What could R not ever be in order to get a circumference? What do you think, Riley? It can't be 0. You can't have a radius of 0. What's another thing that it cannot be? Negative numbers. That's right. So R cannot be negative numbers, and it can't be 0. So if I was to write the domain of R, that's supposed to be a D. If I wrote the domain of R, we would write it like this. We put that little bracket, and we put R so that we know what we're talking about, such that, what does that such that symbol mean? It's just a what? It's just a line straight up and down, okay? So R is a number such that, and now we have to restrict it. So R must be what? It can't be 0 and it can't be negative. So what can it be? Positive. And how do we write positive? We just say anything greater than what? 0. So if R is any number greater than 0, then it's a legit value for R. Does that make sense? That's basically what the domain is talking about, okay? So what are the legitimate numbers that R could be? Well, R could be anything, but here's our restriction, okay? So this means R could be any number, but our restriction is that it has to be bigger than 0, all right? So that's just a little bit more with domain. So that's probably why they put that geometry stuff in there, because of the domain part of it, okay? But we learned something. And we will do some more geometry a little bit later on. Okay, enough of that. Let's move on. Let's go to exponents. Do you remember exponents? Somebody give me one example of an exponent. Something squared. Yeah, that's the first thing that I would probably think of, is something that's squared, like x squared. The 2 right there, that's the exponent, all right? It doesn't mean x times 2, does it? What does it mean? X times itself, right? Okay, so x times x. What if I had a 3? We have a special word for the 3 as well. It's cubed, right? What does that mean? It doesn't mean 3 times x. It means x times itself how many times? 3 times, okay? That's basically what it means. Now, if you want a definition, this is the definition. If I have a to the n, All right. Now, we don't know how many times we're going to take this out, do we? Right? We don't know if it's x squared, x cubed, x to the fourth, x to the fifth. We don't know. But this is basically what they say. It's a, let's see how they write it, times a times a. That's supposed to be a dot right there. Sometimes my dots don't work on this little program. And then you put dot, 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 and then you put another a. So what this means is, how many of these a's are you going to have? Well, you kind of know. Look at this. How many a's are you going to have? N number of a's. Very good. Okay? So you'll have n. That's supposed to be an n. Looks weird. Let's try it again. All right? That's n number of a's. That's kind of the definition of an exponent. So this has a name. That a right there, what's the name of that big number on the bottom? Think of cheerleading. And you got the girls that are, oh, I shouldn't say there's any cheerleaders in here. Sorry, I don't want to offend anybody. But you got the bigger girls on the bottom, stronger girls, and they hold up the smaller girls, right? What do you call these girls on the bottom of the pyramid? The base, exactly, okay? So this is, hope I didn't offend anybody on that one. So right here, this is the base, okay? That's the base, and of course this is the what? It's not a flyer, but it's the exponent. In cheerleading it would be, but that's the exponent, okay? You got a base and you got an exponent. We got it? Okay. Let's do another one. We talked about multiplying by 0, but what if you have an exponent of 0? So if I had a, which means it could be any number in the world, and it's to the 0 power, what is that equal to? What do you think? It's equal to 1, okay? It's kind of a definition, but you could actually, yeah, let's talk about this. I just hate to go by this and not say anything. So I'm getting a little bit ahead of myself, but what if you had this? What if you had x to the, we'll just go to the fourth over x, x to the fourth. What's that equal to? What's anything divided by itself? It's 1, isn't it? Okay. Now here's something I'm going to show you. Yeah, it's actually the next example. So I'm jumping ahead just really quick. But here's another thing, another way you could write this. You could take that first x to the fourth, just write it x to the fourth. Remember, division is the same thing as multiplying by the reciprocal? Well, here's something that we're going to learn brand new, that you can write, let's do this. 1 over x to the fourth can be written x to the negative fourth. You remember doing that in Algebra 2? Negative exponents? Okay, so x to the negative fourth is the same thing as 1 over x to the fourth. This does not mean it's a negative number. When you have a negative exponent, that has nothing to do with your number being a negative number. It just means instead of putting it on the bottom, we flip it to the top and we just change the sign of it, okay? So this x to the fourth on the bottom, I could write it x to the what? To the negative fourth. I don't know if you remember this. I don't think they talk about it in the next little section. But again, I'm just skipping ahead a little bit because I want to show you why this is this, okay? So there's a rule that says when you're multiplying with exponents, you keep the base the same, and we're going to talk, and literally in minutes, we're going to talk officially about this. You keep the base the same. Anybody remember from Algebra 2? What do you do with the exponents? Add the exponents. What's what's 4 plus negative 4? It's 0. What did we say x to the fourth over x to the fourth was? 1. So would you agree that x to the 0 is the same thing as 1? There you go. I think that's kind of cool. Again, a lot of teachers don't teach you that. They just say, okay, memorize, x to the 0 is 1. Anything to the 0 is 1. Just know it. But I like to, when I can anyway, I like to show why it's true. And that's why it's true. Isn't that cool? All right. So you learned a couple new things today. All right. Enough of that. Now, yep, and then, so that's a definition. This right here, it's in the book. That's a definition. And basically, we just talked about the other definition. We got a little ahead of ourselves. But if I say a to the negative nth, all right, how can I rewrite that? It's not a negative number. What do? I write 1 over what? A to the n. So that's another definition. Probably should have said that before I went through this stuff. But I got too excited about this a to the 0 thing, so I had to get to it, all right? You with me on that? That's review, isn't it? Even Algebra 1. I keep saying Algebra 2. You learned that in Algebra 1, probably. It's been a long time since I taught Algebra 1, so I can't remember. Let's do a couple examples. Okay, so this is example 8, and there's several parts to it. This one is part A, and what if I told, and the question says evaluate. It just means figure out what the answer is, okay? Evaluate it. So it's 2 to the negative third. We got to figure out what that's equal to. Now, you're not putting it in a calculator. You're going to do this yourself, okay? You're going to write it down. Remember, a to the negative n is the same as 1 over a to the n. So what's 2 to the negative third then? It's going to be 1 over what? 2 to the third, or 2 cubed. You with me on that? So there's no negative numbers involved. The negative exponent just means you just flip it, okay? If the negative exponent's on the bottom, guess what you can do? Flip it to the top and turn it into a positive exponent. If the negative exponent's on the top, guess what you can do? Flip it to the bottom and change it to a negative, or whatever I said. Okay. If it was negative on top, you change it to a positive, okay? So you can flip your exponents top and bottom as long as you change the sign of the exponents. Everybody with me on that? We're going to be doing a lot of that kind of stuff. All right, so that's what we did. We flipped this to the bottom. We changed it to a positive. Now we can figure this out. What is 2 cubed? Well, it's 2 times what? 2 times 2. 2 times 2 is 8. So it's not 6. It's not 2 times 3. It's a common mistake a lot of students make. But it's 2 times 2 times 2. All right? And that's 1 over what? 8. Again, this has a negative number to it, but it is our, if I could speak right, is our answer negative? No, it's not. That negative just means you flip it to the bottom. You with me? Okay, let's do another example. B. Let's go, well, this is just as easy. Maybe even easier. X to the negative fourth. How would I write that? 1 over x to the fourth. Very good. You got it. You're catching on. That's it. You can't simplify it, can you? Because you don't know what x is, so you just leave it like that. That was a pretty easy one. Ooh, what about... Yeah, what about this one? Ooh, my goodness. Now, this is a little bit crazier. You could, don't write this, okay? Don't write this. Just watch. You could write it like this. Remember what you do with this? You flip it to the bottom. So you put a 1 on the top. What would you put on the bottom? 1. No. You take the whole entire number and flip it to the bottom. So you take that whole thing, flip it to the bottom, you get a 1/5. Okay? And then, if you flipped it to the bottom, what do you change this to? A positive. You could do that, couldn't you? Let's do it. I'll show you an easier way, though. That's why I told you not to write this down, okay? I'll show you an easier way. So 1 over, what's this? 1 over 5 squared. It's 1/5 times 1/5. What's 1/5 times 1/5? It's 1 over 25. You with me? Now, this is division, right? So instead of 1 divided by 1 over 25, it's 1 times the reciprocal, which is what? 25. What's 1 times 25? It's 25. That's one way of going about it. That's kind of a hassle. I'll show you a better way to do it. Let's start with the 1/5 again to the negative second. What you can do is this. Instead of going through all this mess, all right, what you can do when you have a fraction, you can just flip the fraction. But if I flip the fraction, what do I have to do with that -2? Change it to a positive. Isn't that a lot easier? Okay, so when you have a fraction to a negative exponent, just flip the fraction. All right, so what's 1/5 flipped, or the reciprocal of 1/5? It's just a 5. But now I got to change something here. What do I change there? That 5 squared is, isn't that a lot easier? That's what I want you to write down right there. Okay? What do you think? It's not so bad, is it? That's an easy way to do negative exponents. Some people freak out when they see negative exponents, but if you realize what a negative exponent is doing to the stuff inside the parentheses, it's really not that bad, okay? You're not making it a negative. All you're doing is flipping, all right? Reciprocal. I say flip it, but, reciprocal is the correct math word. You good to go on? All right. What do we got in here? 25. Oh, good. I got 15 minutes. All right. I think we can finish this. I'm tired of using that color. Let's go to blue. How's that? All right. So now what we're going to do, and we've actually used one of them today. So I know you guys have been taught this because you guys answered me when I did this. Right there. Remember we did this? And I said, what do you do with the exponents? You add them up. Okay, that's what we're officially going to talk about right now. Okay, so these are laws of exponents. All right, let's do the first one. And they give it a name. They call it the product rule. We've talked about this earlier in the year. What does product mean in math? Multiplication. Very good. Okay, so let's talk about the product rule. Here it is. We're going to get real general. We're very general with this. We're not putting specific numbers in here, but this could stand for any numbers and any exponents. Man, my writing on this thing. There we go. That's a little bit better. And it's the rule we just talked about. Okay, so that thing with the -4 and +4 exponents, that's this rule right here. So now we're officially learning it. So when you have two bases and they're the same, this is very important. Notice they're both A. It's not just by happenstance, okay? It's on purpose. They put the A's the same letter because this has to be the same base. This only works when you have the same base. Everybody got it? That's why they're both A, all right? Now, when you have a multiplication problem, what you do is you keep the base the same, and then you do what to the exponents? You do not multiply the exponents. You do something else. What is it? You add the exponents. So if I was to write this, how would I write it? I don't know what m and n really are, so I just write what? M plus n, okay? That's the rule right there. So it's a multiplication problem, but what do you do with the exponents? So what does the rule tell you to do with the exponents? It tells you to add them up. You with me? For instance, I'll show you why. I'll go super easy. I'll even use the a as the base. We'll go super easy, 3 and 2, all right? What does a cubed mean? It means a times a times a, correct? Times a squared, which means a times a. So what do we have here? How many a's do we have? We got 5 of them. Do you see why we add? Okay, because that's how many a's that you're multiplying together. You're multiplying 5 of them together, okay? And that's how you get that m plus n. Make sense? So if I gave you, let's do a quick example. If I said x to the -3rd times x to the +5th, and it says evaluate it, do you have the same bases?
Oh, yeah.
Yeah, you got the same bases, so you keep the base the same, so you just write it down. Now, what do you do with the exponents? Just add them up, okay? And I'm not going to write it, but what's -3 plus 5? It's 2, and then that's it. Pretty easy, right? It's still a multiplication problem, but you're adding the exponents to get the answer. And this is why you're adding the exponents. Good? Let's do another one. That was the product rule. Let's do the quotient rule. Let's change colors. Okay, let's do the quotient rule. Quotient rule. All right. Make sure I'm recording. Yes. Whew. Almost thought I wasn't recording. I thought I'm going to have to teach this all over again. So here it is. It's a to the m. Again, what does quotient mean in math? Division. So I show division like this. Oops, I don't want an m, I want an n. It's very similar to the product rule, okay? But instead of adding the exponents, what do you think? We're going to subtract the exponents, okay? So we keep the base the same. And when you're dividing, you just take the top one minus the bottom one. So I'm going to go m minus n. That's the rule right there. Put it in a box if you want to. That's the quotient rule. Okay, let's do an example. I tell you what, let's not just do an example. Let's show you why it works. So let's go a to the 7th over a to the 3rd. All right. Actually, yeah, let's do that. So what does this mean? This means there's how many a's on top? 7 of them. I'm not going to write all 7 out, okay? And how many a's are on the bottom? 3 of them. So you're going to have some of them are going to cancel out, right? If you got 7 on the top, 3 on the bottom, 3 on the bottom cancel out with 3 on the top. How many are you left with? You're left with 4 of them. So this is going to be a to the what? 4th. Does that make sense? All right. Yeah, that's the quotient rule. That's for division. Okay, so what do you do with the exponents? You subtract the exponents. How did we get 4? We went 7 minus 3. Does that mean this is a subtraction problem? No, it's a division problem, but our rule says that we subtract the exponents. Remember, always take the top one minus the bottom one. Everybody got it? Don't go the bottom minus the top. Always go the top one minus the bottom one. That's the quotient rule. Pretty easy so far, right? Let's do another one. It's called the power rule. That sounds cool. The power rule. An exponent can also be thought of as a power, right? So if I said x cubed, I could also say x to the third what? Power, okay? So that's an exponent rule. So it would be something like this. So we have an exponent being taken to another exponent. Everybody see that? Can't see it? Is it the color? Okay. Is that better? Okay. So let's talk about this. Let's do a number. Let's go super easy. A cubed squared. What in the world does that mean? A cubed squared. It means we're going to take a cubed and we're going to what? Multiply it by itself. Do you agree? When I square something, I take it and I multiply it by itself. Now we already learned the product rule. So what is the product rule? This is a to the what? 6. So what do you think? What did you do to the 3 and 2 in order to get your new exponent? You added? 3 plus 2 is 6? What'd you do?
So you gotta do the exponent so such it's h cubed to.
Just tell me what I did. What math did I do to 3 and 2 to get a 6? I just multiplied. That's right. Okay, I just multiplied. So what do you think you're going to do with this m and n? You're going to multiply. So the rule says if you have a power taken to another power, okay, you follow me on that? When you have a power, a to the m, taken to another power, or an exponent to another exponent, what you do with the exponents is you multiply the exponents together. How do I show m times n? Just put mn, that's it. Okay, you don't have to put a dot, don't put a little x or anything like that. Just put mn, and that's your rule. Whoops. Okay, that's the product rule, and that's basically how you do it. All right, so let's do one more. They don't give this a name, so we'll just write it out. AB to the n power. I almost hate to even use this word because it's not really what it's doing. It's kind of like, it's not exactly, it's kind of like the distributive property. Kind of, okay? It's not really, but it's kind of like it. So what we do is we take everything in the parentheses. Everything in the parentheses is being taken to what power? The n power. So how do you think I would write this? A to the what? N, and what else? B to the n. And that's your rule. I don't even know what the name of it is. I don't even think they put a name for it in there. Okay, but that's the rule. You with me on that? So everything in here is being taken to that power. We'll do an example on that later. Same thing with division. If I had a over b to the n power, what do you think? This is going to be a to the n over what? B to the n. That makes sense, doesn't it? I mean, if it follows that this is true, it must follow that this is true too. All right? This is kind of like a certain type of product rule. This is a certain type of quotient rule. And there you go. What do we got, 10 minutes? All right, I think we can get this finished. Example 9. Let's do example 9. They got A, B, C, D, E. So we'll do it really quick. X to the negative third. I think we already did this one. Yeah, we already did this one. Why am I doing it again? We'll do it again. All right, x to the negative third times x to the fifth. That's the product rule, so you keep the base the same. What do you do with the exponents? You add them up. Negative 3 plus 5 is 2. Boom, that's it. B, let's do this. We haven't done this one. X to the negative third squared. What rule is this, by the way? It's an exponent to another exponent. The power rule. This is power to another power. What does the rule say we do? We keep the base the same, and what do we do with the exponents? We multiply them together. So what's negative 3 times 2? It's negative 6. A lot of times, the book might say, write all the answers with positive exponents. Is this a positive exponent? No, but we learned a rule earlier today of how to make that a positive exponent. So flip it. So technically it's over 1, isn't it? We don't always write it like that, but technically it's over 1. So what can you do? Flip it to the bottom and change it to a positive. But what's left on top, though? There's a 1 left on top. Why? Because this is always 1 times something. So a lot of math books, math teachers would rather you write it like this. Okay, to tell you the truth, this is still simplified unless the book says write everything with positive exponents. Okay, if they say that, then you must write it like this. If they don't say it, you can keep it like that and it's perfectly fine. Okay? All right, if I'm going too fast, you can always watch the video again, or certain parts of it. You don't have to watch the whole thing. All right, here's that one where we didn't really have a rule, and I said it's kind of like distributive property, but I almost hate saying that because it's really not distributive property. But basically, you're taking everything in your parentheses and taking it to the third power, okay? So let's do that. Even the numbers, even if there's just regular constant numbers in there, okay, we take it to that power. So first of all, we write 2 to the what? Right, cubed, or 2 to the third power, and then what else is in here? An x. So I write x cubed, or x to the third power. We can simplify this. I would not keep it like this because this can simplify. What does that simplify? What's 2 cubed? 2 times 2 times 2? 8. So it's 8 what? X cubed. There it is. They're doing announcements pretty early, aren't they? It's 25, right? We get out of here? Yeah. Yeah. Okay. Let's do another one. We got some time. D. 2 over 3 to the fourth power. Kind of like this one. Come on. Maybe that's why they're doing it 7 minutes early. We have a ninja in our school? All right, here we go. What's this going to be? This is going to be 2 to the fourth over what? 3 to the fourth. Okay? Can you do 2 to the fourth in your head? We just did 2 cubed. So 2 to the fourth would be what? 16. 8 times 2, right? 2 times 2 times 2 times 2. Right? That's 16. Over 3 to the fourth. What's that one? That's a little tougher. 3 squared is what? 9. Let's do it like this. 3 squared is 9. Another 3 squared is 9. That's 4 of them, right? 9 times 9 is what? 81. Okay? And does that simplify? No. 2 doesn't go into both of them. 3 doesn't go into both of them. Nope, it doesn't simplify. We just leave it like that. All right? Let's do one more. X to the negative second over x to the negative fifth. Now, let's assume they're asking you to make sure we have all positive exponents. People aren't packing up yet, are they? We still got 5 minutes. Okay, don't pack up. All right, let's take a look. Let's say we wanted to change this to all positive exponents. Let me show you a nice, easy way to do this. I'll go to a different color. Watch what we can do. Are any of these positive exponents right now? No. So I'm going to have to take this. How am I going to make that into a positive exponent? Flip it. That's right. So I'm going to chuck that down to the bottom. I'm going to take this negative exponent and do what to that? Put it up to the top. Flip it up to the top. So let me change back to white here. So what do I get now? The x to the negative second went to the bottom, and it changes to x to the positive second. X to the negative fifth on the bottom, if you flip it, it changes to x to the positive fifth. It's pretty easy, isn't it? All right. And now what can you do here? What's the rule? It's division. Well, what's the rule? Not the answer. What's the rule? You subtract the exponents. Now you can tell me. It's 5 minus 2, which is 3. And that's what that's equal to right there. So when you have negative exponents, it's usually easier to change everything to a positive exponent. How do you do that? You flip it. Okay? Let's do a couple more examples. This one says, if you look at the example, I don't know what page it's on, but it's example 10. If you look at the example, it says write all the exponents as positive. All right? So I think we have time to do both of these. Let's give it a shot. X to the fifth, y to the negative second, over x cubed, y. All right? And the question says, write each expression so that all the exponents are positive. All right? Well, x to the fifth. Do I need to flip that? No, it's already positive. What about x cubed? Nope, don't need to flip that. What's the only one I need to flip? The y to the negative second. So I'm going to take that, I'm going to flip it to the bottom. What's it become now? Y to the positive second. What happens here? It leaves the top, so I just mark it off, okay? Now, let's simplify it. What's x to the fifth over x cubed? X squared. And that stays on top, doesn't it? You could look at it this way. There's 3 x's down here. There's 5 here. So 3 of these cancels with how many? 3 of these. What are we left with? X squared. You see that? It's kind of a little trick to do. That's what I like to do. What's on the bottom then? This is y to the first. So what's on the bottom? Y cubed. And that's your answer. Are all your exponents positive? Yep, that's what they want. Okay, they ask you specifically to make sure all the exponents are positive. And we did. Last example and we'll be finished. X to the negative third over 3 y to the negative first. And that whole thing is to the negative second power. Time's running out, so let me just go through it quick. I'm not going to ask you what to do. This is y to the negative first. It looks like y minus 1, but it's not. It's y to the negative first power. So what I would do first, you can do a couple things. What I would do first is do my little flippity-flip stuff, all right? So watch. Flip that down to the bottom. Flip that up to the top. So what do I have? I have a 3x cubed. What's on the top? Y. This is to the negative second power, okay? So what do we do when we have a fraction to a negative exponent? Flip the fraction, okay? And then we're going to change that to a positive. So let's flip it. What do we get? We get that. We get that. Oh my goodness, I can't teach with all this stuff going on. Oh. All right, just hang on. Just wait. I'm almost finished this problem. Okay. No, this is the last one, I promise you. So this is what? This is 3 squared, which is 9. This is x cubed to the second. What do we do? It's the power rule. What do we do when we have an exponent to another power? What do we do with those two numbers? Multiply them. So this is x to the what? 6. What about the bottom? This is a 1. So we multiply them. What do we get? Y squared. That is your answer right there. I know I went kind of quick, but you can always review it later on YouTube if you want. Okay? You know what your assignment is, right? Finish the homework. 39 to 83 odds. Okay? 39. I'll write it down. 39 to 83. You're just doing the odds. And it's section R2. All right, look at that. I finished before the bell rings.